So I'm very honoured to, first of all, introduce Kyle. I do know Kyle very well because I keep telling him to knock my office door down with lots of innovations. He's the Digital Engineering Manager for John Holland Group. Kyle has 8 years' experience in the construction industry, delivering projects across residential, commercial and infrastructure sectors in both Australia and New Zealand. Some notable in projects you will see every day in terms of Westgate 3B that many of you drive past, I guess, on a regular basis. Sydney Gateway, if you ever, I mean, most of you have been to the airport. Sorry about that, because between Gateway and Port Botany, Mr. Fleck, we're really making an impact there. Numerous support roles on large-scale road and rail tunnelling projects in Australia. Kyle is formally trained as an architect and strives to use these skills to find and establish connections that are not obvious. And I think what Kyle does an amazing job on is he pushes the boundaries and tests the limits of what history says, to use the best of where we've come from, but to push the limits on where we're going to go. So I'm going to welcome Kyle to the stage. Thank you for listening to me, and over to Kyle. Thank you.
Hi everyone, thanks Steve for the introduction. So as you know, my name's Kyle Forlong. I'm a Digital Engineering Manager with John Holland. So what we're going to do today is just look at digital engineering, and I think maybe just before I start, I think it's important, actually, I took a lot away from that first session and the points around digital engineering, not so much focusing on the technologies that we use as technologies, but more so about what they enable and improve within our industry. And that's actually a lot about what this presentation is really going to do, is how those tools are actually maximizing those processes that we go through every day on our projects. So I will kick off. Oh, it worked, great. So I guess just to start off with, it's important to maybe understand a little bit about where we are digitally in our projects. A lot of people might be familiar with models and BIM and all those sorts of things. Others might not. Now, I think it's fair to say that, you know, the construction industry as a whole has been lagging behind in terms of its digitalization. I think you know, we rank only just slightly higher than hunting and agriculture, which is fairly interesting. But you know, that's where we were, and it's not to say that we are still there. Definitely not by a long shot. We're making strides every day to get better, and I think what's really important to note about that is that that change is coming very much, or being driven by our clients, who we're delivering for. You know, we have the likes of ARTC, RPV, Transport for New South Wales. They all have a digital future in mind, and you know, a lot of the conversation is now not so much about can or should we have BIM on our project. That's gone out the window. It's really now the default expectation that our projects will be digitally enabled. They will have 3D models, and those models will be data-rich models too, not necessarily just geometry that is nice to look at. Now, that's a really good core core to work with, and that's where we are now, where we've got a huge amount of opportunity in the industry because we have that information appearing on projects as a default. So what are we going to do with it? Well, lots of things. As a whole, to start off with, there's the more sort of core benefits that having that 3D design in front of you enables. That's things like coordination in the traditional sense, which we'll cover, which is permanent state elements intersecting with elements, understanding how they are meant to interact with each other rather, but also pushing that even further and looking at not just what the permanent state is, but how we get to that. And that's things like temporary works, bringing that out of the 2D into the 3D environment, understanding the actual methodology of construction and what those implications are in terms of, laydowns, plant movement, people separation, all those sorts of things come into play, and they can really change the outcome of how we get to where we need to. And that also encompasses things like safety and design as well, so we'll cover a little bit of that too. The other one, which is still not quite understood, but moving in a great direction, is data and analytics. Now, because we have client-mandated sort of expectations around attributing non-graphical or, text, parameters, values, all those sorts of things, quantities, putting those into models, we're actually able to extrapolate that information or metadata and understand trends and look at what projects and what models and how the design is actually functioning day in, day out, which gives us a really good opportunity to sort of head off at the pass anything that may, potentially become a sticking point or an issue in the future. So one of probably the most common ways that you'll ever interact with a model is through a federated model. We have these on all of our projects. We use tools that are called issue management tools. One of the most probably industry-wide uses of that is Revisto as one. That's a cloud-based platform. So what it means is that we're able to bring all of these various 3D models that are produced by our designers, our subbies, and ourselves also together, so that we can actually understand the wider context of the project as a whole, rather than sort of looking at discipline-specific siloed pieces of information. So we'll use a federated model for that, and that environment is one where we bring all of the various stakeholders together. So you've got us as design management, construction teams, we have the supply chain, and we have our client and key stakeholders involved in that process too. And they're all looking and communicating with one another, using the model as a, vehicle or as the base of that conversation, so that it's much easier and, to understand what we're actually talking about. So coordination comes in a lot of places. I'll touch on this quickly because it's not terribly interesting. It's just graphs. But coordination as its base. We have things like clash detection, and where we add value there is that we as the digital engineering team, we sit with design management, we sit with construction teams, and we say, okay, so we know the high-level premise of this thing shouldn't touch that thing, but what actually is the specific considerations that you need to make on this project in specific areas, timing, all those sorts of things, and we can factor that into what we're doing to build a nice, really robust set of parameters that we can apply to the model and ask it questions, and it will return to us those automated sort of responses or from that we can work through to sort of improve the permanent design. So this is really talking in context of the design development piece, I suppose. And what that actually looks like, as I mentioned, we have Revisto, so we're able to raise, issues that are actually, geolocated within the model, and it gives our users the ability to then, talk across the model, send messages, sketches, all those sorts of things. So right there, we're improving communication and sort of bringing this layer of transparency into the design development that isn't really achievable when you're just looking at a 2D plan. There we go. Now the other piece that I mentioned is temporary works. Now temporary works, traditionally you see it only really in a 2D sense, and the amount of times that's caused problems on site for things that you couldn't really account for when you're looking at a flat sheet of paper. Just last week I had, oh goodness, lots of fires to put out. But so that's where we get involved. Now, there is the sense that we really want to be sort of looking for those, subcontractors and designers that are able to provide us that information in 3D and getting better about how we scope them and factor that into, our budgets and whatnot. But when that doesn't happen, obviously the DE team is available and has the capability to step in and sort of fill that gap. We don't like to do it, but we can do it. So in the case here, you can see we had a bridge that had these temporary supports that needed to be attached to it. that, prior to the decks going on and whatnot, nobody thought to think about the sort of implications of it having a 1.2 metre overhang, below the bridge, and what that meant for the kinetic envelope until a few days before they had to go up. So, bringing digital engineering into that, we were able to, see that there was an issue and sort of head it off at the pass before it became a problem, and they couldn't reopen the line or had to take it down or something in that nature. Easy wins there. So one of the other things too is sort of understanding that these models, they represent a design intent, but they are fairly indicative of what ends up happening. Now this project here, this is WestConnex 3B. I know it's not rail, but just as an example. So you can see on the right, you've got the actual design model of these utilities in the ground, and then to the left you've got the built reality. So that was that's not survey, that's what we said we were going to do, and it worked out in the real world because we put so much effort into making sure that we'd considered as much as we could at the design phase. Carrying on. So another way that we can add value to a project, again, is through introducing more context information and sort of lengthening the conversation rather than just looking at that permanent design. So a few ways that that happened, you can see on screen here. In this project, we had a scope requirement to have consideration for a future siding that wasn't, that was going to be built in the future, and we obviously had a large sort of grouping of utilities that had to run through that area. Now, conveniently, the scope only really had a screenshot of a drawing with 3 coordinates on it that we had to then demonstrate our consideration of to the client. And one really easy way to do that is bring that into the model. So we were able to take that string, apply some geometry to it, and sort of demonstrate, yes, we've considered it, and this is what it looks like. Some other areas quickly, things like temporary fencing, which don't seem like a huge thing, but they are when it comes to signal sighting and whatnot. Again, a 2D thing only. We could bring that into the 3D model to give better understanding of the site. And another one just quickly is looking at groundwater levels. So again, that's probably typically you might see that in your GIS portal or something, but actually bringing that into a 3D model also just, again, gives more context and understanding of what's going on, but also how that model and design interacts with the real world. And finally, too, things like delimb fencing and whatnot, we can actually bring that into the 3D model, and that'll sort of lead me into where I go with construction sequencing and modeling and things too, so that we can enable more conversation around safety and design, and also constructability, all those sorts of things. So construction methodology, this is huge. This is my sort of passion in this industry. And this is sort of that second layer of coordination. It goes well beyond just looking at the permanent state, and we start actually thinking about how we're going to do something before we go out and do it in the field. And it really allows us to sort of tease out all those sort of little intricacies that you wouldn't really be able to detect until you're trying to do it in real life. So it gives you those benefits in the planning and space-proofing spaces against those actual site conditions. We also can leverage it for other things. So, that whole doing more with less, we've got this information, what more can we do with it? We can use it for, site inductions and the like, and training opportunities, as well as engagement, stakeholder engagement, which, actually I'll touch on later, but is a big thing in the front of mind for clients. And then it gives the construction teams that ability to visualize their work packaging logics and, make adjustments accordingly to make things actually buildable. So you can see a few images here of various construction methodology. Now that was at a macro scale, so it's you might have seen these before, and you might have been looking from 10,000 feet down at a model sort of appearing out of the ground. Now we can go to a more granular level of detail, and again, we're just using what we already had. Now in this sense, what we end up doing is getting quite heavily involved in things like activity method statements, those sorts of things, excuse me, we're actually able to go into that micro level and understand things like the slewing of a crane, or how a girder in this case is being lifted over a rail corridor, and sort of give, flesh out and give life to a method statement and make the client more comfortable with what we're proposing to do. And these have helped us immensely on places like Gateway as well. Like for example, just really giving surety is they know all the contents there technically in a 2D sense, but this really just brings it to life and enables people to be more comfortable that we've actually thought about what's going on. So we use the two interchangeably, but they both provide a huge amount of benefit. You can see here too, this was just an example to the client to show that we could slew a crane and lift a precast concrete shell for a bridge pier adjacent to the corridor without that impacting the corridor, so we could actually visually demonstrate what the lift plan said in 2D. And as well too, this is one of our lifts that we've done over, this is a removal of existing bridge, just showing, what the context of that lift actually was. Quickly as well, concept optioneering. So again, the DE team brings a capability to produce content as much as it does interact with content produced by others. In this case, we like to inject ourselves into that optioneering space too, and be a conduit to sort of explore options through the design phase, and provide value in that sense. A little substation there. And the big one is stakeholder engagement, I think. Now, our clients are becoming very mature digitally, and stakeholder engagement is a big part of what a lot of them are mandating as part of that delivery phase. What you're looking at here is an example, again, from Gateway, which is one where we conducted our signal sighting for the corridor virtually, completely within the model. Again, using our permanent design models that we already had and some reality capture of the site, so photogrammetry. We could overlay the two. That included things as well, like bringing in that temporary fencing that we did earlier as well, building up an actual vision of the world, and then conducting our signal sighting, and we got that through, which was a first in Australia. So that's quite we were happy about it, I suppose. Again, and this is not by any means going to any greater lengths than what we already had. It's not hard to do. It's just thinking about other applications for models because we have them on hand. Again, that's just a view from the driver's perspective. So you can see they get a pretty good understanding of what's actually in front of them from these models. This is actually built in the same software too that we use for our 4D animations and whatnot. In this case, you're looking at something called Fuser. So we're using tools that have multiple applications as well, which is really important. Just briefly too, so it doesn't stop there. Again, in that content creation space, and thinking about constructability and things, is also looking at access and maintainability. So things like 3-dimensional swept paths, that's really important. In the case of this particular instance, I think we had the intention of using a particular forklift, which was obviously bigger than the door. So that got picked up fairly quickly through that process of actually visualizing it, because in 2D it was obviously narrow enough and was able to run the path, but it wasn't until we thought, oh well, let's just check it, that we discovered the issue. Now I apologize, it's data, it's boring, I know, but data is that other sort of really not quite as understood sort of area of digital engineering, and there is a lot of benefit that can bring to a project too. So as I mentioned, we will take those sort of data requirements that end up becoming clients' asset information models and populating their asset systems, we're able to extract that from models, validate it as the design is progressing. So we're able to give really clear, consistent feedback to our supply chain on all of those areas that they need to pump into those models. Now, but what's really cool about that too, though, is that we can take that information and we can extract analytics from it around earned value, or just how the design is progressing, all of those sorts of things, just by nature of it existing. When I talk about model validation and things too, so we will validate that information on behalf of our supply chain and give them really clear feedback on where there's potential gaps or inaccuracies in that data set, and we're able to send that, work with them, have them in the same environment, this reporting environment, so that they're able to make changes quickly and effectively, rather than it being a sort of afterthought that we get lumped with at the end, and figuring out how to actually build an asset system out of sort of half-baked information. Yeah, it's great in that sense too. Yeah, that's hopefully that gives you a little bit of perspective on some of the ways that we're able to leverage these models. It's a interesting field. It's evolving all the time. I mean, I could talk for hours on this stuff, but I've only touched really some of the very basics things around geometry. There's lots of technological advancements and things going on that are just awesome to watch and see. So yeah, thank you.